Hello there. I am Hemel, and this is the presentation for my master's thesis, a short demonstration of the application that we have developed for this thesis. Let me first introduce the motivation behind this work. In today's world, the way we consume news is changing rapidly, but with endless information streams and all the possible echo chambers and the biases, it really becomes hard to trust what we read. So this thesis was motivated by this simple question: can we build systems that not only summarize the information, but also reveal the hidden perspectives, detect biases, and give readers more control over the narrative they see in news and journalism fields? So we had done a previous project before on AutoJourn framework, and we are extending this work of automated journalism, that is automatically generating news from social media conversations, with all these problem statements and their solutions. To explore this, we designed a prototype application, an automated journalist. It brings together all these several concepts from the natural language processing. First, we explore topic extraction with dynamic topic modeling. Then we do perspective extraction and perspective-aware summarization. And finally, bias detection and neutralization, followed by echo chamber analysis. We also added an extension of fake news detection and dealing with the fake news in our generated news. So here it is. My supervisor Ahmed, Mosharafa, and examiner Georg Groh are part of this thesis with me, who have guided me through. Let's explore what we did. So this is AutoJourn, and this is basically the pipeline for our application. So we have some stages in this. Stage 1, where we search a query and find out certain social media conversations from several REST APIs like Twitter, Instagram, Telegram, etc. Also Reddit. And then we do dynamic topic modeling, where we try to formulate the topic based on the conversation. And once we have the topic, we also extract several perspectives from the chat. And with the topics and perspectives, the system being aware of it, we get the different summaries and a merged summarization. We use up all this content to create news. We use several LLM in the backbone. We sometimes fine-tune the prompting and use several kinds of prompt mechanisms, 0 shot, 1 shot, few shots, to create these results. And then in the stage 2, when we have the generated news article, we use it to do bias detection and bias neutralization. For that purpose, we also have some fine-tuned models to do it in the backend. Also, echo chamber analysis from the generated news article and stance shifting on the article to give the users the freedom to shift the stance and rewrite the news. This is what we have also done in this application. And finally, in the last stage, we have extended another feature of fact verification or claim verification and dealing with the false claims. Let's see the application now. So this is the home page of the application, where we have 3 options right now: Twitter, Reddit, and Telegram, from where we extract the social media conversations. For example, let's select Reddit and search some keyword like, let's say, trade wars. And there the REST API works and searches for the results. The most popularly discussed results from Reddit will be automatically shown on screen once the results are up. And then we will use those conversations to make our further analysis. So here are some of the conversations. Let's go with the very first conversation thread. And here we have a button called Summarize Text. So we click on it. Okay, for now we have this option to do dynamic topic modeling with GPT-4o in the backend, and we select that and we save it, which triggers the OpenAI API, which uses GPT-4o as the model in the backend, and this starts analyzing and gives us a set of topics along with their distribution pie chart and the percentage probabilities of the topics. Now, the topic with the highest probability percentage is 30% is trade wars and economics impact. So this page is designed like this, where we have the option for getting the summary on the conversation based on the topic and the several multiple perspectives based on the topic and the text. So what we try to see is this topic, trade wars and economic impact, if we have multiple perspectives extracted. Also for the perspective extraction, we are using some one-shot prompting in the backend using the same GPT model. And now we click on the topic and we get some perspectives. And we see there are 75% of the perspectives agree and 25% of the perspectives disagree. And if we click on these agree buttons, it expands into the perspectives and gives us certain reasons. What does it agree on? And if we click on the disagree button, it gives us reasons and criteria based on which it disagrees on. Now that we have all these multiple perspectives on our hand, we can do summarization because it is perspective-aware summarization. Hence, now we click on the summarize button and it loads the possible summaries. One on the agree version of the perspective, another on the disagree version of the perspectives. So we have the agree summary and the disagree summary. And then we merge the summaries and it merges all these perspectives and summaries together into one single summary, which contains all these perspectives. And once we click on the merge summaries button, it invokes the LLM prompting behind and it gives us a merged summary result. Now, once we have these merged summaries, we have the button to generate the news article. We click on this button and there we select the topic again that we have, which we have generated the summary for. It uses that merged summary of the perspectives and we choose a particular style. For example, let's go for formal style of news generation, and it takes it all in the background with the prompts that we have designed after continuous testing, and this loads into some news. So news article is generated by now. Here comes our next phase where we do a bias detection on the news. So we hope that this news, however it is generated, it might contain certain levels of biases. Let's click the detect bias button and it will invoke our fine-tuned bias detection model from Hugging Face and show us what are the biases in this news article. And it already has shown us with the highlights on these sentences that these are biased. And if we click on this, each of the sentence, we get a particular bias detection score and the bias type it has, and also the confidence for the bias type. So clicking on these sentences gives us a good analysis for the different bias types and their confidence. So we have several kinds of nationality bias, socio-economic bias, and then we have some political bias over here. So we have all these kinds of biases in these particular sentences. For this, we can also have this option to download a full report. If we click on the full report button, it downloads all the data related to it. and we can get a PDF. So this gives us a report where we have the text, we have the topics, we have the distribution of the topics, and we have their perspectives. We have the summary, we have the generated news article, and then we have the bias statistics in only the bias sentences of the news article. So we see there are a total of 31 sentences, and out of which 8 are biased. So okay, we can say 25.81% is biased. So we have a bias distribution, and afterwards we could do a neutralize bias button. Also, a fine-tuned bias neutralization model is behind this. And if we click on the neutralize bias button, it will invoke that model that we have in the background, and it will deal with the only biased sentences, and it will transform them to some neutral content and replace those sentences over here. So we have the neutralized sentences. Now, actually, with these neutralized sentences, we have the option to replace bias. If we click the replace bias button, then it will replace the original news article's biased sentences with the neutralized sentences. And this will give us this pop-up with the finally bias neutralized article. So this is one thing that we have done. And now that our article is bias neutralized, if we click on full report again, it downloads the report, but now the report is more or less updated. So there you have the original generated news article, and at the end you have a bias neutralized article also. This gives us a complete report until now. So this is what we have done on the bias detection and neutralization front in the application. Afterwards, we have in the next stage included an echo chamber detection. So if we click on this detect echo chamber button, it will invoke an echo chamber detection model behind the screen, and this will analyze all the conversations there is and create a graph for echo chambers. But obviously, the graph takes some time, but now the graph appears, and we have this conversation graph. And in this conversation graph, we have the colored communities, which basically are the echo chambers where one speaker is echoing the other speaker in those communities. And they reaffirm their beliefs, which we called confirmation bias. And there it happens a lot. So we have polarities. It can be political polarities. It can be several kinds of polarities. We can download this image. And once that image is downloaded, we can open the conversation graph and we have the results. And now we can close this. After this feature, we have another feature, which is echo chamber stance shifting feature. So if we create the echo chamber button here, so it gives us some possible stances like this: anti-Trump and pro-Trump, opposite bailouts for farmers, support bailouts for farmers. So suppose this gives the user an opportunity to change the stance of the news according to the needs of the user. So if you select this button up here and you are like pro-Trump, this will change the article on the right side of the screen according to the stance. So it's more pro-Trump in nature, and the stance will be skewed towards a pro-Trump article. So this shifts the stance of the articles over here. And now whatever article we have is a stance shifted article. We have done echo chamber analysis, bias detection and mitigation, all of this on this article, which is obviously perspective enriched from the conversation and everything. Afterwards, the last stage appears where we are doing some fact checking on the article, because this article is predominantly created from social media conversations and available knowledge from the web. But if we do some fact checking, we might find some untrue facts, and we can do some verification of that and evidence grounding on that. So let's do some fact checking. Verify factuality button, that's what we click here. And this opens up a new page for us, and it gives us extracted claims from the article. So we have several claims here. Now we have to deal with every claim one by one and verify them, because this fact checking part adds up a latency. Otherwise, as it is itself a very standalone block, it can serve as a whole different application itself. But for this application project, we kept it together in one pipeline, so it can add some sort of latency if we do claim verification altogether for all the sentences at once. To deal with that, we are doing claim verification one claim at a time. Hence, we have all the extracted claims here. Now, suppose we select one certain claim here, starting from this one, let's say, and we click the verify claim button. It totally invokes a whole pipeline of claim verification that we developed in this thesis work. And then it does all the API searches over Google, over News API. News API gives us some evidence grounding from news websites, so real news is involved here. Google search is involved here to check for certain sorts of evidences. And then afterwards, it will come up with the evidences here. And so we find the results on this side of the screen. On the right side, we see it's a mostly true claim. We have some evidence summary over here, and we have all the sources also given together. And these sources are links. So we can click on these links, and actually we can go to the sources and we can read the source to verify also. That means we can add some sort of human supervision to it, because these are the links based on which it is said it is mostly true. So we can verify these links manually also whenever we want. And then, let's go for another something like this claim. Let's verify this claim, and let's see what comes as a result. So as it is seen that for every claim, there are some seconds of time delay involved. So this latency is there. So this claim is actually true this time. So there are this scale of results: true, mostly true, false, mostly false, completely false kind of results. So it's important to check every claim, and it's better if we find something not true. We can also have a possibility to correct them. But till now, whatever claims I have seen were actually true. It's not possible to correct them. Only the claims which are mostly false or false are the ones that we can change in the article. We have a pipeline behind that. But here, okay, so let's see, this claim looks a little bit dubious to me. Let's select this claim and let's verify this claim. Maybe this claim is not completely true. And if it is false somehow, we will have an opportunity to show you how to correct the false claim also. But our prompts are so well designed that it is supposed to give us mostly true claims, and that also is kind of an evaluation of its own, that our generated article is self-evaluated here on this part, where we can always check for false claims. And if there are no false claims, definitely we have a very nice article. We have no false claims in our article. but I will show you verifying every claim present here, and that will be more robust. And if all the claims come out to be true, then we don't have any issue with the end result of this application. So this is the completely end stage of this application. So if you show something like this, obviously you cannot show it because there is nothing to correct. So yeah, but there is an option to download the corrected article if it is corrected. And basically that's it. That's the complete demo of the whole application that has been done till now. We have a full report from the application also present, and a claim verification pipeline up and running. And also we have all these things. So what we have discussed till now is this particular stage 1, 2, and 3, and 4, where we have generated news with perspectives and summary based on all the perspectives, all enriched with that in the news. And then we have done some bias detection, followed by neutralization of it. So not only detection, but how to deal with biased sentences. Then we have addressed the problem of possible echo chambers in the social network conversations, and also stance shifting, giving freedom to the users to generate news of their kind. And finally, we have also addressed the problem of fact-checking in news, which can be a standalone application itself. Bias detection also can be a standalone application itself. So basically, this one application is like a mother application which combines all the standalone modules of itself together in one application. So at the end, we have generated news, which is perspective enriched with all the details and updated with the news API and the web results. There are facts verified and according to the stances selected by the user. But the user in this case could be a journalist or news media agent or somebody working in that field. They can see these results. They can augment these results with their work and basically speed up their work of journalism through this. And this will help them to make a better way of creating good journalistic articles. So that's it. That's all what the thesis was about. Thank you so much.